primary objective of this PWM driver is to leverage the best features of each automotive microcontroller and optimize the implementation based on the automotive ECU requirements. As such, this specification defines the selectable levels of features and functionalities of the timer peripheral and maximize the use for the best capabilities in our application code. To generate the PWM signals via automotive MCUs using this AUTOSAR MCAL layer APIs for which this PWM driver library is part of, we have to do certain level of configurations and methods and chronology steps to follow. At first, we need to configure the microcontroller pins in PWM peripheral mode via the port driver. We can generate the PWM signals from microcontroller through different peripherals like timer peripheral of the MCU, or there is a one more flex IO peripheral. So at first, selection of microcontroller pin has to be done from PWM signals has to be generated from which pin, and that pin has to be configured in corresponding peripheral mode, and this thing is done via the port driver library of the AUTOSAR MCAL layer. After that comes the clock selection and configuration of MCU driver. As I said that microcontroller, the PWM works in the terms of counters, and each counter increments like the variable counter increments from 0 to its value. How much time it takes for an each increment take is dependent upon the clock which is fed to the PWM peripheral, the timer peripheral, and the clock to the timer peripheral is fed via the clock selection of the microcontroller, and this clock selection is done using the MCU driver of AUTOSAR MCAL layer. So MCU driver is responsible for clock configuration and settings of the microcontrollers, settings of system clocks, peripheral clocks for each peripheral that has to be fed to the microcontroller are done by the MCU driver. And for generating the PWM signals, what clock frequency has been input to the timer peripheral is very important to calculate the parameters like frequency and time period. After that, there is an MCL driver selection is also very important, as we can generate the PWM signals from microcontroller via different peripherals, as I said, either timer peripheral or flex IO peripheral. By tradition, timer peripheral is what is recommended and widely used, but this flex IO peripheral is new and very emerging peripheral which is coming in automotive microcontrollers. The PWM driver can also be like PWM driver library of AUTOSAR is designed with a global level and the industry-wide coverage. So it is also dependent on the flex IO peripheral. So we need to include the flex IO peripheral concentric files, and these files are being included by the MCL driver. Flex IO peripheral is an extra and an advanced peripheral. So all the extra and the advanced peripherals of the microcontroller are part of the MCL driver. So we will just select the MCL driver in our GUI configuration, and dependent files for the PWM driver would be included of the flex IO peripheral, so that even though we are not gonna configure the flex IO peripheral, we are gonna use the timer peripheral only in this functional demo code, as this is the part of timer peripheral. Flex IO peripheral would be part of our higher and advanced courses. After all these configurations are done, then we are gonna go and do the PWM driver configuration and selection. That is what is the main motto of this course: how to configure the PWM signals, how to configure the PWM duty cycle, frequency, which pin has to be configured, which channel, and their PWM mode, which type of PWM signal we want to generate, edge aligned, center aligned, complementary. All these things are then done in the PWM driver configuration and by the PWM driver library, and that is what is the part that is what we are gonna understood in depthly in this course. Also, if we are using the interrupts, so then there is a use of extra module, the platform module or the platform driver, and that is responsible for configuring all the interrupts of the microcontroller on an automotive case. So we are going to use the interrupts also in a PWM signals so as to detect the each rising and falling edge, or that is each transition from high to low and low to high, so as to understand things in a very depth and better way. So that's all about the PWM driver of AUTOSAR MCAL layer. These are the steps which we will be following so as to use the PWM driver, and so as to use PWM driver with any automotive microcontroller you are gonna do by the AUTOSAR tech stack using the MCAL layer.